Hi everyone, welcome back to the channel. Let us start our today's problem. Just give me a second, I'll just check if we are live and connect my microphone. Yes, we are live. So let me show you the problem statement. It is largest binary search tree in a binary tree. So let's have a look at this problem statement. What you have to do in this question is you are given a binary tree, okay? Please mind it, it's a binary tree, not a binary search tree. You have to find the size of the largest subtree which is a binary search tree in that particular tree, okay? So if I look at this test case, you have 1, 4, 4, 6, 8, okay? Do you find any subtree which can be a binary search tree? And if you find more than one such subtrees, you have to return the size of the largest BST. Let us take this example and understand. Okay, wait. Let me open this question. And write it 6, 6. So this is your test case. Got 6. Then we have 6. Next up we have 2. Then we have is 8. Then to the right of 6 we have 3. To the left of 3 we have 9. Then we have 3. Then we have one more 8 to the left of 9, and then we have 2. So first for that, okay, what would be the brute force approach? What can you think of it? First of all, you know that this is a binary tree. Now a binary search tree can be any subtree, right? For example, for this 6, I have to check if its left subtree is a BST, its right subtree is a BST, and they both follow the property such that this is less than 6 and this part is greater than 6. How will we ensure it? Okay, so one possible thing could be that you pass every node to, we have already solved a question which is BST, whose task is that it takes a root value, root node, okay, node root basically, and it checks if it is a BST starting from that particular node, okay. So this function takes on of time complexity, and actually I'll be checking this thing for each node, okay. So basically that will be on of that n square of time complexity. But in that also, that's not all that you can do traversal in any order. You traverse through every node, you check, for example, for this node you check is it BST, it returns true because it's the single node. Then you check for this node, you check is it BST. For example, if I see this subtree, it's a BST, right? 2 left is null and right is 8, which is greater than that. This only this part is a BST. Also simultaneously I have to check what is the subtree's size that I'm getting. So this is of size 2. Then I go further above in my tree. For example, I'm just giving an example, not that we are going to solve using this approach, because we have a better one which we'll be discussing. Then let's say I go at this tree. If you even want to check if it's a BST, for example, you send this node and check is BST. So your BST's task is to check for the other nodes in the tree, so that for that it will go back to all the nodes, okay. You can do it in any way. I am showing you in bottom up approach, but actually you can go do it from top to bottom. For example, you are sending up this tree, it will straight away say false, okay, this entire tree is not a BST. Then if I pass this node, what will it say? Left is null, okay, fine, but because of this 2, it's not a BST, so it will return false for this tree also. Then you go in the traversal, then you go and check for 2. For 2 it returns you true, and but in that case you'll also have to keep the track of what is the size of such a binary search tree, right? So this is one approach. But the problem is that, as you can see, for every node I am traversing through every node. Then for every node it is making a call to is BST, which further is of on of time complexity. So what better can you do? So from here itself, in this discussion itself, I've dropped some hints which can help you think about what we actually need to do. So forget about is BST and all. Just think of it in this way also. For example, if I make sure for every node, if I can check if it's a BST, and so on and so forth, and I keep a track of its size, what extra thing would I need so that I can ensure that I'm getting a BST? Let's understand it here, what I mean to say. For example, you check for 8, fine, you check for 8. For 8, you know it's a single node, it will be BST. So 8 says I am a BST and size right now is 1. Okay, then I go further to its root. Okay, because there is no left, I go directly to 2 now. So it will say, it will, for example, if this subtree is a BST, for that I need to have, first of all, which left node I have. In this case it's null. Okay, I don't have to worry about it. But in my right subtree I have some node which is 8. I just need to know that node, because there is only single node right now. So I can just say, if this node itself, its data is greater than my root node, then I can say it's a BST. So this particular subtree follows the property of a BST, and my size now becomes 2. Okay, so this part is a BST, fine. Let's check if I have a bigger BST. Then I go to the root, because there are no left nodes, I directly go to 6 now. So 6 will ask, for me to be a BST, first of all tell me what is there in my left. Here it is null. Then I ask what is there in my right. So we know in right we have 2 nodes, 2 and 8, fine. But how will it know what are the nodes, and if I am the smallest of all the nodes that are present in my right? Because the property of a BST is that root should be less than the right nodes, okay, and should be greater than its left nodes. Okay, so if I can know from right which is the smallest node in the right side, because if the smallest node itself turns out to be greater than my root value, I can safely say that all the nodes to my right are going to be greater than me. Does that make sense? Same goes for left side. I know root is supposed to be greater than all the nodes present in the left side. So if I can say that I can track which is the largest node in my left subtree, and if my roots is still greater than the largest of all nodes in my left subtree, and root turns out to be greater than the largest of left subtree, and it is less than the smallest of right subtree, I can say it will follow the property of BST. Makes sense, right? So just that, if I can have the track. Now if I check in the right subtree, because there is no left subtree, I'll check which is the smallest in my right subtree. It is 2, but 2 is supposed to be greater than 6. So here itself it fails the property, and my size so far comes out to be 2 of a BST. Correct? Now since this subtree on the whole turns out to be not a BST, so 6 will not, means any tree whose root will be 6 will not be a BST anymore. Reason being its left subtree is not a BST. Got it? So whatever values I pass from here, it should make sure that now 6 does not have any point of comparison for it to be a BST. How we will do that, I'll show you in the code. But now the chapter for this part at least ends here. Whatever subtree I had to get, I got it from this portion. Now same goes for this subtree. Okay, I have to check the similar thing for, okay, you have to follow one order of traversal. So what kind of traversal are you going to check? You know, in order to have this comparison, have a look at this line. In order to have this comparison, you need to have traversed your left subtree also and the right subtree also. So for the best traversal for that, in which you have traversed left, then right, and then your root will be a post order traversal. So clearly we are going to use post order traversal. So we have not come at 6 yet, but we are going to now check for the right subtree. So there are, here also we are going to follow the post order traversal. So left, right, and then root. So I am standing at 8 right now. 8 is a subtree, fine. Then I'll check for 2. 2 is a subtree, BST. Why? Single node, okay. Then I have to check for this condition when I come at their root. When I come at their root, I will ask which is the smallest value in my right subtree. It is 2, and this value itself is less than this. So clearly this is not a BST. If this is not a BST, what min and max values will I pass to this root? We will see. First check, let's check for this right one. So this right one is equal to this one. Okay, let's see if they are considering the equal ones. Equal ones are not considered to be BST, right? It has to be greater than, it has to be less than, and then the root value, the left should be less and right should be greater. So what I observe from here, if I ask for 3 is a sub BST, but when I have to check this condition, when I come at this 3 as my root, I'll see that my left subtree does not return me the largest value that it returns me. Okay, ideally root should be greater than the largest of my left subtree, so I will return such a greater value that root will never, such a value that root will not be greater than that. So what can I return? Int max. For example, if I return int max from my left subtree, because now I know that this is not a BST and I want this comparison to fail when I come at 3, right? So what can I ideally do? From my left subtree, I have to pass the largest of my left subtree. So pass int max as my largest, because if this int max, this integer max value will always be greater than my root value, right? My root value will never be able to exceed this value, right? And this is the condition that left subtree largest node should be less than my root node. So here itself it fails this condition, therefore I will not find any BST from here. I haven't found any BST which is greater than size 2 so far, because this was a BST but it was of size 1, this was a BST of size 1, this was a BST of size 1, and thereafter from now this whole as a subtree is not a BST, so I have to return, I am making comparison. In this condition I have to return some small, which will be the smallest value. Are you going to return 2 for this subtree? Not at all. Why? Because this subtree first of all is not a BST anymore, so there is no point of making this comparison pass for this 6. That is why the smallest value I'll pass will be my int min, so that this root node will always be greater than this int min, and ideally it should have been less than that, right? So I hope you're understanding the gist here. Whenever the subtree fails the condition of a BST, my idea is to pass the min value, whichever is expected, in such a way that this condition fails. So the best way is this, right? Similarly, from my left subtree I was passing int max, so that 6 will always be less than that value and this condition will anyway fail, right? And hence whatever size you got from this 2 and 8 was the maximum size of the subtree that you found. Got it? So this was about this question. Let's have a look at the code, and then from there I'll take the code again and do one dry run on some other examples so that you can understand the intuition and everything that we discussed here. So let me just a second, I'll quickly take some good example. Let me see if you guys have any doubt so far. Okay, so for example, if I take a tree like this, let's have a look. This is 50. Okay, so if I want to check for this case, what I'm going to do, let me show you the code also. See, now for every node is associated with some min value, maximum value, and the size that I want to pass, right? And also I'm making sure if that part of the tree, that subtree, is following the property of a BST. So what we are doing is we are creating an extra class. Okay, this class is going to have these 4 parameters with it, and this is a constructor in which we are initializing this, the standard practice which we do. So each node will be associated with these 4 informations that I'll keep track of, and then there is this function which will return me this class is of type, class is info. Okay, the name of the class is info. So the return type will be of type info. Finally, what it returns me that for this root is BST, what is the min, max, and the size. Okay, finally I'll get this information from the function that I have written here. I'll just take this part and give you a dry run over this example so that you can clearly understand whatever we discussed, how is it going to execute. Fine. Okay. Fine. So guys, now considering we are keeping track of 4 parameters, which is BST, just small, make it small. So one is going to be is BST, one information. Every node is associated with min, what is the minimum I am getting from the left subtree, maximum, and the size that I am getting so far is my maximum size. Okay, so let's see. This is your base case condition. Your function is fine. For example, this is your function in which you are passing those things, and this is the code that you are writing. Now, starting from this, if your root, this the base case condition, no, we are not falling into it. Let's check making a call to this function for your left subtree, okay, in which you are passing 30. So you made a call to this function by passing f of 30, correct? And in that case, I'm just writing here, right now your max size is 0. What you passed initially was 0 only. It's 0 right now. Then fine, you made a call, then you further go here and make a call to 5. Right now your function is made call to 5. Okay, now the next is null. So the moment you find null, you return new. First of all, you know, whenever we have the leaf node, it is going to be a BST, so we return true for that. And what values do we return? So when you get a null value, basically what do you return? Your minimum is going to be integer dot max value, for example infinity, and your maximum will be minus infinity, so that you can always make sure that the root node is going to be less than this value. Sorry, it is always going to be greater than this integer dot max, means integer dot min value, which you are getting from the right subtree basically. In short, it is passing this condition, should be less than the smallest from the right subtree, okay, from your right subtree, and should be greater than the largest value of your left subtree. Okay, this is the condition. So 5, something is missing here. Integer dot max value you're passing from, one sec, min, max, and size. Okay, fine. So your size is, this is for the null node, okay, min, max, and this is your min value, this is your max value, and this is your size, which is going to be 0. Fine. Next up, when now I have already made a call for 5 will be removed. Now I'll make a call for the right of it, which is 20. So for 20 also, when I go further, I'll find a null node. I'll return this new class in which I have stored is BST, min, max, and the size. This will be returned to 20. From here now, have a look. Left has been traversed, right has been traversed. Now I am at f of 30. So what is the size? Size will be, so if for example, if this is a BST, so what will be the size of this BST? The size you'll get from left, this will return you what? The size that it will return you will be 1, correct? The size that it will return you will be 1, fine. So the size of this entire subtree will be 1, the size you get from left, the size you get from right, plus yourself, so it will be 3. Let's see how we are handling it in code. So finally, once you are done with left and right part, you calculate the size, which is the left dot size. So left is that class info, correct? So left dot size should have the size of the left subtree, which is 1, okay? Right dot size will have the size of the right subtree, which is 1 again, fine. Because when we were at the null node, we came to we executed all the lines, which I have not taken while I was explaining. I skipped that part, assuming that you will understand it, but here I'm reiterating it, that it must have calculated left and right size as 0 for the left and right null nodes. Then this part has calculated its own height as 1, size as 1. So left will have its own size, right will have its own size, and the size for this will turn out to be 3, correct? Now let's check the condition if it is falling into that condition or not. So before that, let me see what is the maximum value. So if I want to store the max for this, subtree, the maximum will be root dot data, whatever is your root dot data, and math, whatever maximum you are getting from left dot max, which left dot max will return you 5, right? And right dot max will return you what? 20. So what is the max? See, this, we are storing this information to be passed to 50 if this turns out to be a binary search tree, right? So it has already generated its answer, which is 5, right? And for it, it is 20. That means the smallest from here I will get is 20, and the largest value from left subtree will be 5. Then I check for this condition. If root dot data 30 is greater than the left max, yes, left max 30 is greater than, 30 is definitely greater than 5, and is it less than 20? But no, it is not less than 20. This condition fails here. Root dot data should be less than right dot min. So this condition, since it fails here, we will not return this information, rather we will return this. So this subtree on the whole will return a new info class which will have the value is BST will be false. Your minimum will be the min value which you generated, which was already present. So your min was stored with what? I think it was integer dot max or min, whatever it was. So what did we pass? Your min and max, whatever they will be stored with, will be passed to this 50, but is BST factor is going to be false. Okay, so right now we have not processed for this. We will directly through the post order traversal, we are still making a call to f of 65. So the next call will be made to f of 65, let's say f of 65, f of 80. Now when I am at this, I will be checking for, this condition, the minimum that you will get from the right subtree is 80, okay, and 70 should be less than this, which is true, and the maximum from right is 65. This follows the property of a BST, so it returns this new info in which is BST factor is going to be true, and min, max, and size that it will return is going to be 3, correct? Okay, and what will be the minimum and maximum? So see, the minimum will be 65 and the maximum will be 80. Got it? Okay, let me write it here, 65 and 80. Fine. Now from here, it is itself is a BST and it will return true, and the min max both will be 45. Now I'll check this condition for this 60. Let's check. So 60 will see what is the minimum value from the right subtree. So what is the minimum from the right subtree? You know the minimum and maximum from your right subtree. So you choose the minimum out of it. So 65, it will check itself. Is it less than 65? Which it should be. Okay. So I'll see the minimum from the largest right subtree is 65 and 60 is less than 65. So this condition is true, and the maximum from left subtree is 45 and 60 is greater than that. So this portion altogether comes out to be true. So it will return new info with is BST factor to be true. Okay. And the minimum from here will be, see, the minimum I got from here was 65. The maximum I got from here was 45. So first of all, it will evaluate its size. The size will be 1, 2, 3, 4, 5. 5 is the size that it will return, and minimum value will be the value you got from here, 45, and the minimum 45 will be the minimum, and the maximum will be 80, right? Maximum, your max was already stored with 80. You just calculated the minimum you got from left, the minimum you got from right, and the minimum of these two will be stored in your left. This is what these lines are doing. If you want to update your max, you are checking your root dot data and the max, whichever will be the greatest of these three values. What? Left dot max, right dot max, and the root, and same goes for left. So now when I return my info to the is BST factor will be true, and your min will be 45, your max will be 80, right? And your size is 5. But the thing here is that this condition, when I check for 50, this condition will not hold true. The reason being the left subtree is BST factor, left dot is BST, this factor is going to be false in this case. So any one factor if of these, of all the conditions which we have put here using and, if it is false, so this if condition will fail, and hence finally the answer that I'll get will be the info that I'll return will be this info with is BST true, size will be 5 and min and max. Okay, this is what I'm going to return. Otherwise I would have returned this factor if, for example, 50 including 50, this all together was a BST, right? So in that my size would be 5, 6, 7, 8, 9. Okay, so this size I will retrieve in the final, in this function which your compiler had already provided you. So I'll return the max size from there itself. Okay, so I hope this thing is clear to you. If you guys have any doubts, you can ask me. Okay guys, I can see your, if you have any doubts, I can see that. Please let me know. If not, then that was all for today. Fine. So have a look. If in case you joined class a little late, whatever we discussed has been already covered. You can go to the video and check that. Okay. Fine, then let's wrap it up for today guys, and see you all in the next lecture. Bye bye and take care.